Well, hello everybody. This session is all about product design skills, and that means what you should be able to do and what you should like, what you should want to become if you want to be a product designer. I'm a product designer, and I've been teaching product design for 15 years, and I have an additional 10 years of industry experience, and I can walk you through the steps of what to expect if you're going to be studying product design, if you want to be a practicing product designer. I think the first and foremost thing that you should be capable of is critical thought. This is not really a difficult thing for us in Western countries. Western culture is very good at questioning the status quo, and you should always hone that skill. I am of the opinion that the first thing a student of product design should be awarded with when they join the program is a t-shirt like this. A t-shirt with the print, "I can do better than that." And with that, I mean, you should be the kind of person who's never happy with the way things are. It's okay, we are paid to be these negative people. And I can tell you, you will be in a very difficult place if you like things the way they are. Because if you like them the way they are, you're not going to propose changes, and that is what we are in the business of doing. We know what exists, we think it may require improvement, and we show that kind of improvement. Where does that put us? What kinds of people are we within the society? The typical product designer is actually a generalist. This means you know a little bit of everything. As a designer, you should be so open that no matter what somebody brings you, it will be interesting to you. I've made this little graph here, which I hope shows reasonably well what the different capacities are of different professions. You will see here that engineers, for example, engineers will understand, of course, engineering, management, research, prototyping, and a little bit of accounting, but there are these long stretches here where they are not covered. Some professions are even more one-sided. So here, accountants themselves, for example, I would think, know only about accounting, but they may not know about PR or marketing or management as much. Now, we designers up here, in theory, we would know a little bit of all of that stuff. We designers know about engineering, about management, about research, about prototyping, about marketing, about accounting, and about PR. We may not be experts at any of these, but we know enough to be able to interface with these people, and we have an interest in what goes on in all these other fields. That makes us a little special because it means we are able to talk to anybody about anything. So we are generalists, people with a wide range of knowledge and interests. And if you feel you aren't like that yet, but would like to be a product designer, well, maybe start developing that trait in yourself. You'd be amazed how interesting things are, even if you currently aren't looking at them. Another thing that defines us is the ability to have original thoughts. Original thought is a surprisingly difficult thing to do, and that is why we are special. There is a bit of science behind this. They call this the creativity quotient. So there is a test by Malcolm Gladwell called the divergence test. And Gladwell is of the opinion that you'll get two kinds of people in the world. One type is of the convergent profile, here on the left. The other type is of the divergent profile. The convergent thinking profile will usually come to fairly conventional conclusions about things. So if you have a lineup of words like this down here, Here's one column, here's the other column. These are all nouns, these are all adjectives, and you're supposed to pair them up. Now you might say crocodile, stupid, car, beautiful, chair, comfortable, bird, funny. These things make sense, and your average Joe in the street is going to think this way. No offense to any Joes. And then you've got the divergent thinker, which is what we should be, we designers. Feel free to look like this if you like. And we will combine the uncombinable. We will do things like crocodile mild, the mild crocodile, or the funny chair. We will do the strange things, the unexpected things. And only a few people are able to do that, and that is, in a nutshell, how originality happens. Okay, so you would need to be like this group of people here on the right hand side. There's another little psychometric creativity test by Guilford. This is about the uncommonness in replies. What Guilford does is he will show people something and then record how they interpret this. And the more uncommon the response, the more creative the person. So when we are looking at these two smiley faces here, we have two candidates here, one proband on the left, one on the right, and let's see what they're going to be saying. Now, this incredibly witty person on the left identifies the two smiley faces as round. Now, that is a down-to-earth answer, but unfortunately that does not make him a designer. Now, let's see what the person on the right has to say. He is of the opinion these are probably Uruguayan guerrillas in disguise. Now, this is one hell of a strange answer, and if you are like that, guy, then I think you have a bit of a designer in you. Another thing that we need to have as designers is initiative. Initiative to innovate, and innovation is one of those buzzwords that everybody uses and nobody really understands. So I'm showing you here the 4 different faces, not phases, but faces of innovation. The first kind is the so-called sustaining innovation. Please don't mistake this for sustainable innovation. It has nothing to do with being good to the environment. Sustaining means keeping something going, keeping something up to date. And that is why I have put cars into this slide, because the car industry quite typically uses this approach to innovation. They will simply update the next new model to the point where it's good enough and fresh enough for the market, but it still resembles the previous one so that it has full recognition value. So they're doing just enough to keep things going. That's sustaining innovation, which is maybe not the most radical type there is, but it is a type that we should be able to perform. And we perform a lot of that as industrial designers. The next thing is a disruptive innovation. Disruptive sounds a little more, and it can be. Disruptive innovation means your client or manufacturer still makes the same thing, but they change a major aspect of it, such as if it's a car manufacturer, they switch from petrol cars to electric cars. So that would be disruptive innovation. And for you as a designer to propose this, well, you would need to know that you're proposing a pretty massive change already for the standards of this client. You may be surprised that research can provide us with innovation, but especially for us designers, we create what is called conceptual designs, and they are research approaches in themselves and also involve a lot of research activity. We do these things to find out what is possible, what things would look like that we haven't tried before, and how the public would react. So that is another kind of innovation that we should be prepared to do. We experiment. And then finally, you should be open to this. Not every designer is an inventor, but you could create a breakthrough innovation, or at least be asked to work with one. If we stay with the car industry as an example, let's just say a company discovers teleportation. A car company discovers teleportation. They would no longer make cars, would they? I mean, if you can just beam yourself away, as on Star Trek, there's no more point in having cars. So this would be a totally revolutionary idea, and designers can also provide those. So this is an innovation matrix, and as designers, R&D workers, research and development workers, as we are classed on job sites, we should know what these four types are and how to use them and when to use them. Now that we've brushed on research, it may surprise you, but as a designer, you must be able to do a lot of research, and you need to be able to do it well and quickly and deeply. What we do is we capture whatever ideas we have, and there are various ways to capture ideas. I've put them all here on this slide for you. I think you will agree that this is pretty much everything we have at our disposal to record our ideas. You can draw it, you can put it on a sticky note and plaster them all over your office. You can keep a diary, you can film it, you can take pictures, you can write it up on your computer, and you can do a voice recording. Maybe there are others now, but at the moment I cannot think of any others. But the main thing is you need to have a tool or several and a habit of recording your ideas, because these things are treasures and they're worth a lot. Now back to that research part, which leads to the generation of ideas. Research is not something we do lightly. Research is a very formal thing that follows certain procedures, and you will do it systematically with the intention to actually increase the stock of knowledge. Now, what we mean by that is we need to know what is out there, and then we build on that. So we don't reinvent the wheel, and to avoid reinventing the wheel, we try to educate ourselves really well on all the existing solutions that are in that area that we're working on, so that we don't accidentally propose something that somebody has already proposed 30 years ago, because that is very embarrassing. Other things that we do with the research is we establish or confirm the facts of our project. We don't want to assume, we want to know. We want to be absolutely 100% certain that what we are using as data is true, and we do our best to get the best data before we even start having ideas. You may also perform research to try if something proposed by somebody else earlier actually works. You may want to do that if you're going to put it into your own design. We try to solve problems, new or existing, and we may even develop theories as designers. But now back to the fun part here. What makes a good designer is them possessing specialized technical knowledge. Specialized technical knowledge meaning you know things that aren't commonly known, and they will be about techniques and technology, such as If you're looking on this page here, there are a number of interesting things that probably mostly only designers would know what they are, and you would be expected to know what they are. So here we have these chairs, and they're pretty interesting in terms of how they're made. So this is probably laminated wood, laminated over a mold. And we know all these kinds of materials and processes in industry. We know how it's done. So we can talk to our manufacturing people. And this is something you will need to learn if you want to be a product designer. We have knowledge about these kinds of drawings, how to make them. This is a sketch rendering, or a marker rendering, I should say. And as a product designer, you'll be expected to know how these are made, how to handle markers to come to this kind of result. Here we have a 3D printed object. 3D printers are quite common, and we use them all the time. They're a very convenient way to turn our computer models into something we can actually touch, and you would be expected to know how that works. You're also expected to be able to draw anything you like, sketch anything you like, make a computer model of anything you like. You will be expected to understand ergonomics, which is all about the comfort of the human body. And you need to have the ability to create models. So here, for example, we see what is probably the pinnacle of model making in industry. This is a transportation designer creating a full-size model of a car. So these are typical materials you see down here, and you are going to have to use them during your studies as a product designer. Here we have blue foam, for example, and on it you put this chocolate colored stuff we call automotive clay. This is usually heated up in kilns or ovens to about 40 degrees. It becomes pliable and soft then, and it is then applied to a substructure of this blue foam. And these modeling irons down here are used to sculpt a perfect shape out of them. Following this, people usually do fiberglass lamination over it, and that is how the body panels of a car are made. But you'll find that this kind of technique for model making is also used for electronics and furniture. It is a very common way to end up with a final model. The whole chapter of 2D visualization is important to understand if you want to be a designer. It means you should be able to create images like these. It's a beautiful image. I don't know who it's from, but this is considered good industry standard stuff. We have here very realistic looking shading and highlighting. Perspective is flawless. It has been captioned in flawless writing. This entire drawing serves to communicate what was in the designer's mind. So it's basically a monitor to your brain, and you're putting on paper what you're dreaming about. So you need to have good drawing and sketching skills to be able to do this. And you need to have good computer modeling skills to be able to do this. There is an army of different computer modeling software suites out there. Me, I'm a Rhino guy. I like Rhino 3D. It's just something I stumbled upon a few years ago, and it just stuck. It's a nice, easy handling software, but there are others that are also very, very nice. 3D Studio Max, SolidWorks, Blender, they're all nice, good softwares for their own purposes, and they should all be able to give you this kind of imagery. It looks like a photorealistic, well, it looks like a photo, doesn't it, of an object that really doesn't exist other than inside my little computer. And incidentally, I find that one of the most fascinating aspects of being a product or industrial designer these days, that you actually have these wonderful tools to create photorealistic imagery of what really only exists inside your head. It goes for everything. You can make furniture, vehicles, things, you name it. I'm sure you have seen images like these before, and they're still getting better and better all the time. Yeah, definitely something you can get yourself lost in. I must have built, I don't know, 5,000 different of, just because they're so easy to build, and it's often easier to build computer models than to start sketching them all up and stuff. There is then the actual model making, which you also need to be able to do. We expect a product designer to make models at a very, very high level. So if you're not a good model maker yet, better get into that. It is important. Just a few examples of models, good models, and how they were made. Here's a complete paper model, mock-up really, of a camera. It doesn't work, of course, but it is a great visual representation of what the camera might look like. And of course, you can use things like printers and photocopiers and computers and photos to help you enhance the appearance of these kinds of models. Here we can see a lot of things that were probably never handmade, but this was probably put on a well, it was probably made in some software like Illustrator and then printed off and cut out and stuck on. And we do these kinds of things. It's not cheating, it's expressing your ideas to the highest possible degree of detail. Here we have a cardboard helmet. Wonderful piece, just to show you what's possible. Blue foam is another very prolific material among product designers. It has a few advantages and a few disadvantages. Some people are quite good at sealing it and painting it up, but I think that is taking it too far. It's a fairly cheap foam that actually comes from the building supplies side of things, and it cuts very easily with either saws or craft knives or even glow wires. It sands quite well, and you can quite quickly build whatever you like out of it. Not a very high cost. You can also use MDF, which is medium density fiberboard. It's a fairly cheap wood product, and it paints up very well. It's a bit heavy, but if it's just about making mock-ups, for example, or certain kinds of prototypes, perfectly fine. For this, you'd need to have access to a bandsaw and other power tools, but most design schools have this, and you would be expected to take an interest in these machines and use them. Here's the slightly more advanced sibling of the blue foam. This vehicle is made largely from yellow foam. You cannot see it because it's been sealed and painted wonderfully. This is from the Jaguar Museum in Coventry. But when you take a closer look here, you can see that yellow foam, and that is what it actually looks like, that yellow foam. It is a lot harder than the blue foam. It doesn't get any indentations. It doesn't give, really. And when you sand it, it behaves almost a bit like sandstone. It crumbles off in small sand-like crumbs. It's a much more precise modeling material and makes one hell of a mess, so you may want to have a vacuum cleaner handy if you use this. It is expensive too, so this is the kind of thing to make final models from. Here we have our industrial plasticine, or automotive clay as they call it in the car industry. I have already mentioned that earlier. These days, we often find that 3D milling, 3D milling is used to get most of this material shaped, but it still takes a lot of handwork to get all the reflections to run the right way. And that is something we are interested in. There is nobody else in the company, in the entire research and development process, who is qualified to take care of visual detail as much as we are. It's us who are responsible to make sure the shadows are where they should be, to make sure the highlights are where they should be, to make sure the reflectivity is right, the colors are right. All this stuff is what we do. We also get involved in the making of prototypes to varying degrees, obviously, because this is beginning to be engineering territory, but the engineers will need us because we are giving them the initial stages of this thing. So we are often finding ourselves part of the prototyping process all the way through. Also, because things will need to be changed and people will want our opinion on how it should look. So a prototype may be changed every now and then, and we need to have input in that. There are, I would say, two different extreme kinds of prototype that exist. One would be the purely functionality-oriented prototype. Everything on it works like on the real thing, but it may not look like the real thing. And then there's this, the opposite. It's a visual prototype. It may look like the real thing, but it may not work. So here we have a BMW coupe with a beautiful body that is completely shaped here with the industrial clay, but it is just a wooden scaffold with some blue foam on it and the clay. So this won't drive. Still we need it because the body panels are made like this. Well, and then last but not least, there is the implementation of everything. And you know, I used to believe when I started in industrial design that I don't have anything to do with that. I always thought, yeah, you know, once it's off my desk, the engineers will take it forward and that's that. But it's not true. We are actually part of this step as well. There are a lot of business meetings. There is a lot of talking. There is a lot of Skyping. There is a lot of trying out of stuff in factories, in supply companies. And it is important to be comfortable with this. So I know it is quite common among designers to be not real people, but you should be aware that this is coming at you. If you are going to be a designer, you will be surrounded by a lot of people who are serious professionals who will be expecting you to be on board every step of the way and have your say on certain things. And it's not just once, but twice or 10 times, 20 times. You will find yourself in this kind of situation over and over and over because you're an industrial designer, a product designer, and there will always be people along the way, and you need to get along with them and be professional. The aspect of presentation and representation is a very important one for product design. You will often find yourselves standing up, speaking to people wearing ties and suits. People who may be funding the project, people who may be legal representatives of something, or engineers. And it is therefore important that you're comfortable speaking freely to a group of people who may not always be nice, who may not care if you live or die. This extends to the sector of finance. You will very likely, sooner or later, have responsibility at some level, which means you will have a budget to work with. So you need to know what it means to work with money within a company or for your own company, or generally as a designer, what a budget means to you. Where does all that money go? And where does it come from? So do take an interest in finance and take an interest in leadership. There is a word called design leadership, and that is, I think, the minimum you may want to have. Design leadership, being able to perform within a group of other designers and perhaps even take the lead on projects. Because every now and then you will do that. You will, even if you're just a cog in the big machinery, you will still have your own projects and you will be accountable for them, and there will be people working under you, with you, and you will need to have that skill to relate to them in a professional sense. It may well be that you're moving up into management. A lot of people do, which means discovering all these other things that have to do with managing people. You need to be able to delegate. You need to be able to find the right person for the right job and so on. I won't get into this now, but I'm just giving you this as a head. It will be important that you know certain legal aspects of the profession. So you'll want to know about contract law. This is for your own good, obviously, because once you graduate, you will probably want a job and you will want a contract for that job so that you're secure. Or you start your own company and then the heat is on with contracts. And you will want to know as much about that as you can to keep yourself safe. And then there is intellectual property. How to get a patent, what to put a copyright onto, when to apply for only a design patent rather than a full patent, and so on. So all these aspects should be part of your design education, and if they're not, well, you've been warned. Might as well try and grab hold of these things. So far my overview. I hope you found that interesting, and I have a few other videos here uploaded as well. I hope you can find those if you escaped this one. All the best in your studies.